Hi, I'm Ms. Cho, and in this video, we're going to see how to check if points are solutions to systems of inequalities. Systems of inequalities are like systems of equations, except that instead of having equal signs, we have inequality symbols. However, the meaning of a solution is the same. A solution is a coordinate that makes all statements of this system true. Let's take a look at how to see if a given point x, y is a solution to a system of inequalities. Our first example asks, is 3, 4 a solution to the system of inequalities? It's very easy to check, just 2 steps. First, you plug in the point to all statements in the system. Then you ask, are all my statements true? For this system, I'm going to set up a t-chart so I can check if each statement is true. So first, y is less than or equal to 2x plus 1. I want to know if 4 is less than or equal to 2 times 3 plus 1. And then y is greater than x squared minus 5x plus 7. I want to know if 4 is greater than 3 squared minus 5 times 3 plus 7. I'm going to fast forward through this and do the algebra. Since my second step is to check if all statements are true, I'm going to look at this last line where I've simplified. Is 4 less than or equal to 7? Yes, that's true. Is 4 greater than 1? Yes, that's true. Since both of them are true, then 3, 4 is a solution. Let's try a second example. Here we are asked if 2, 1, and 4, 9 are solutions to the system below. Recall our 2 steps. I'm going to set up 2 separate areas, one where I can check if 2, 1 is a solution, and one where I can check if 4, 9 is a solution. I'm going to create a t-chart and check both statements for each point. I'll fast forward through this part. Now I can see if all my statements are true. So for 2, 1, I have 1 is less than or equal to 5. That's true. And then I have 1 is greater than 1. That is not true. Because they are not both true, this is not a solution. With 4, 9, I have 9 is less than or equal to 9. That's true. And then I have 9 is greater than 3. That's true. Because both of these are true, 4, 9 is a solution. I can also verify this by graphing on Desmos. To type in the first statement, I'm going to type y is less than, and I hit the equal sign, and Desmos automatically converts that to the less than or equal sign. This is 2x plus 1. Notice that I have the line, this is y equals 2x plus 1, and I'm shaded below it because I'm looking for values that are less than this line. I type in my parabola, y is greater than x squared minus 5x plus 7. And you'll notice that the parabola is shaded above because this is looking for values that are greater than. Also notice that the border of the parabola is dotted. This is because the symbol is greater than, it's not greater than or equal to. If I added the equal to, it would become solid, but without, it's dotted. Now I'm going to put in the points that we checked algebraically to see visually where solutions can be found on a graph. I've graphed all the points that we checked algebraically and also some extra non-solutions just to see. As you can see, our solution is either in the overlapping shaded region or it's on a border where it's solid. In contrast, our example 2, which is not a solution, is on a border that is dotted. And you also have non-solutions out here that are just not in the overlapping areas. Let's summarize. To find out if a point is a solution to a system of inequalities, algebraically, you plug in the point to each statement and see if it is true. If all your statements are true, then it's a solution. On a graph, you look for points that are in the overlapping regions. If your points are on the border, you have to pay attention. If the border is dotted, then it is not a solution. And if it is solid, it is a solution.